In this video, we will discuss a question. A copper wire has a diameter of 0.5 millimeter and resistivity of 1.6 into 10 to the power of minus 8 ohm meter. What will be the length of the wire to make its resistance 10 ohm? How much does the resistance change if the diameter is doubled? So basically there is a copper wire which has a diameter of 0.5 millimeters and resistivity of 1.6 into 10 to the power of minus 8 ohm meter. Now what will be the length of the wire to make its resistance 10 ohm, and also what will be the resistance change if we double the diameter? So that is the question given. So how do we solve it? So this is the copper wire which has a diameter of 0.5 millimeter and resistivity 1.6 into 10 to the power of minus 8 ohm meter. Now for the first, whenever any question is given, you have to just write down the values that are given in the question. So first, diameter is equal to 0.5 millimeters. So diameter is 0.5 millimeters, and diameter can also be written as radius. So R is equal to D by 2. So D is 0.5 by 2 into. So millimeter is not the standard unit. So we convert into meters, which means 10 to the power of minus 3. So R is equal to 0.5 by 2 into 10 to the power of minus 3 meters. Now rho, that is the resistivity, is given in the question, that is 1.6 into 10 to the power of minus 8 ohm meter. So rho is 1.6 into 10 to the power of minus 8 ohm meter, and resistance is 10 ohm. So now the length should be what to make the resistance 10 ohm? So resistance is 10 ohm. So we have to find out the length. What will be the length? So we are solving the first part of the question. So we know R is equal to rho L by A, where rho is the resistivity, L is the length, A is the area of cross section, and R is the resistance. So we need to find out the length. So L is equal to R pi R square by rho. So area can be written as pi R square. So just rearrange the equation and substitute all the values. So we know R is 10, pi value is constant, which is 3.14, and R we know it is 0.5 by 2 into 10 to the power of minus 3 whole square by rho. Rho is 1.6 into 10 to the power of minus 8. Now if we solve this, we get 122.6 meters, which is very well equal to, or we can just write it as 123 meters. So instead of calculating it in decimals, it would be easy for us if we just shift it to the nearest one. So it is 123 meters. So the length should be 123 meters to get the resistance as 10 ohms. Now let us go to the next part. What will be the resistance change if the diameter is doubled? So now let's double the diameter. Now, if the diameter is doubled, that means the radius of copper wire is also doubled. So, initially A1 is pi r square and A2 is pi. In this place of r, you have to write 2r because r is doubled. So, it is pi 2r whole square. So, if you just cancel, you will get pi cancel and r square cancel. Then you get 1 by 2 square is 4. So, it is 1 by 4. Now, for the same length and same material wire, you know resistance is inversely proportional to area of cross section. As the area of cross section increases, resistance decreases, and as area of cross section decreases, resistance increases. Now, if you can see, R2 by R1 is equal to A1 by A2 because they are inversely proportional. Now, if you just write down, you can see A1 is A1 and A2 is 4 times A1. So if you just cancel A1 and A1, you get 1 by 4. That means R2 by R1 is equal to 1 by 4, which means R2 is equal to 1 by 4 R1. So the resistance becomes 1/4 of the original one. So we solved the question. So the resistance will be 1/4 of the original one if we double the diameter of the wire. Thank you.